Hello and welcome back to my Allen Bradley PLC test bench. Today is a follow-up video to the one that I did before about testing of the IF16 modules. This is going to highlight both the OF8 and IF16. In this particular case we're going to be testing in current or milliamp mode, and I've got two OF8s in the chassis feeding into one IF16 so that each channel is separate. There's no jumpering together or anything else. Everything gives a separate test, and all of the channels from the outputs to the inputs should all be within a few counts on the screen. So this is a pretty simple thing to do, but it's much easier than trying to do it with a meter or anything else. So what we'll do is we'll get swung around here. I'll show you the chassis first and how things are wired up, and then we'll go over to the screen and I'll show you how the configuration is set up. And to be able to read things easily on the screen, you have to have both the outputs and the inputs configured to the same data format. In this case we're using floating data, so it's much simpler to see. So we'll be right back, get swung around, and see you in a minute. Okay, here we are at the chassis. So pretty simple and straightforward actually. Here's our first analog output, our OF8, and it's tied into the first 8 channels. Our second OF8 with the orange wires is tied into the bottom 8 channels. And it's plugged into the current mode channels of the output, and this is all set up over here. All of these are jumpered together because common is common for single-ended mode. Now let's see if we can see here. There we go. Get this straightened out. There's our analog output wiring showing voltage and current, and as you can see on there, it shows that different terminals for different modes. And if we go to the back of that page, hopefully you can see there's the manufacturing drawing that shows how it's put together. So, and there's all your commons there. So it does show that there are different components that need on this card, and they both need to be tested separately. So that's it for the easy part there. We're going to go over to the screen here. Okay, not sure what happened there, but I kind of must have hit a wrong button on the camera. So what I was doing was going to go over here. Here's my DC logic test switches, which are tied into, really hard to see here, my DC input module. And I just wrote a real simple little program that that's 0, 2, 4, 6, 8, all the way up to 20 milliamps output from each card into the input card. So I'll just get swung over here a little bit, and so you can see the screen, make sure it's got it focused right, and be right back. Okay, we're back. So here's the logic that I've got going on. First is the analog output for slot 3, then the analog output for slot 4, and then down here is our analog input, which is in slot 2. And in the center, hopefully you can see that here, of course, there we go. Now if you wanted to pause the video for a second and read that, that's just what I said. If you don't, well, here we go, carrying on. So I'll just back up here again. And, ooh, there we go. So as you can see up in the top corner, or the rung above, you can see the value that we're putting out. Currently it is 10 milliamps. And if we go down a little bit, you can see that all of these channels are sitting at around 10 milliamps. So if we just zoom in so that it's a lot easier to see. So And you can see it bounces around a little bit, which is standard for any analog sort of signal. Digital to analog, and there is no real load here. We're talking about the input card is the load for the output card. So there's 9 milliamps, and there's 18 milliamps. You can see it shows a little bit low, but that's just the way it is. There is 4 milliamps, and there is 0. Now, 0, interestingly enough, you see how it's got the E and then it bounces all around. 0 is a relative term. I would generally not put 0 in for an output. I put 0.1 or something, just so that your numbers stay steady. So that's the really simple part. So if we go back over here, we open up the configuration of the card. Now this is our analog output card. Just get down there a little bit and focus. Okay, so this is our card in slot 3. It is, the COM format is float data. Because I'm swapping cards all the time, I always leave it on disable keying. We go into the configuration tab. Now here's all of our configuration where you set up your data. And because we want a 4 to 20 milliamp or 0 to 20 milliamp range, our low signal down here is 0. Low engineering is 0, which is how we get our 0.0 on floating. High is 20, high engineering is 20, and in the right hand side you can see that the output range is 0 to 20. Now you can also, if you wanted to, you could have that plus minus 10. That's the only two options for this card. You can mix and match on any card. So the other thing you have to do is on your output limits, this tab right here, this is where you can limit your output. Now right now it's low clamp is 0. Just bring that back over this way a little bit, makes it easier to see. There we go. So our low is 0. Now if we could set that at 0.1. Our high is 20. Now if our valve or whatever device it was only took 19 to get all the way open, you never want to slam them all the way. You could change that number to whatever is appropriate. So now that we've changed something in this screen, you can see up here where there's a little star beside the limits. To make that, and this is on channel 0, so we hit apply. It comes up with the warning box. So if you're doing this online, be aware that you may affect production. Save the changes. Back up a little bit so you can see that. I sometimes hate doing these things. And there's a whole thing there that you should read. Say yes. And it's done. So now, we go back up and we look, and our star is gone from there. So we close this box. We look at our channel 0, which is this one, and the 0.1 doesn't make a lot of difference, but it makes a little bit. You can see how it's steady. Oop, helps. You can see what I'm seeing. There we go. There's channel 0 and 1. Now you see, because we put in 0.1, you see how that data for 0 is a lot more stable than it is on channel 1. So that's just something to keep in mind when you're working with these things. That's about it. Come back often if you'd like. Subscribe if you'd like. You can also hit the little notification symbol to let you know when I've posted something new, which isn't that often anymore, but I will be doing a few more here hopefully this coming month. Thanks a lot for coming by, and we'll see you next time.